Good afternoon to my favorite class. Sorry I had to be out again today, but I know you really didn't want to miss the product rule, so that's why I made you this fun and exciting video on how to find the derivative using a product rule. All right, so here we go. Here's the thing, and some of you are going to catch on to this quickly, and it doesn't really matter if you figure it out or not. A lot of times when you have a product, it's possible to use your power rule with a little manipulating of the function. So I'll kind of show you, you can do either way. So unless they specify which rule you have to use to find the derivative, it's really up to you to determine which way you want to do it. So let's say that we are given a function and you have two products, so you're multiplying things together. The rule, basically what we have here is the u and the v represent the factors of your product. So in this case, like if you just look quickly to number 1, your factors would be 3x minus 2x squared and 5 plus 4x. So there is a little typo in here. This should say plus. Okay, so in order to find your derivative with the product rule, you're going to do u times v prime plus v times u prime. Hazard of typing quickly. Okay, so this is just some of the other things that you could see. So your two factors could be represented by f of x and g of x. So it's just different ways of all saying the same thing. All right, so we're going to find this derivative. Now, I want to show you the relationship between the product rule and the power rule. If I was to multiply this all together, so if I was to just use good old-fashioned double distributing here, we'd get 15x plus 12x squared, and then minus 10x squared minus 8x cubed. And then that would turn into 15x, and then you have like terms here, so plus 2x squared and minus 8x cubed. So with that being your function, if you were now going to use the power rule to find the derivative, so using power rule, we would say that the derivative was 15 plus 4x minus 24x squared. Okay, and then that would end up being your derivative. So you can take a product and multiply it out and then use your power rule. So it's your choice. So you just have to keep in mind that if I tell you specifically to use the product rule, then you have to use the product rule. So if you don't like multiplying out and you would like to use the product rule, here's some of the things you have to do. So in order for you to kind of keep things straight, I highly suggest that you identify what u and v are. So u is your first expression, so that would be your first factor of your product, and v would be the second one. And then u prime, you're going to take the derivative. So use your power rule here. So 3 minus 4x, and v prime would just be 4. So the formula says take u and multiply it by v prime. So we're going to take u. So let's see. So our derivative is going to equal 3x minus 2x squared times v prime, so times 4, plus, now we're going to multiply the other way, so we're going to take v, 5 plus 4x, and we're going to multiply it by u prime, which is 3 minus 4x. So yes, some of you are thinking like, wow, this seems like a lot more work than the multiplying and doing the power rule. Sometimes it is, sometimes it's not. Okay, we're going to do a little distributing here. So we get 12x minus 8x squared. We have a little double distributing to do here. So 15 minus 20x plus 12x minus 16x squared. Now this is just a matter of combining your like terms. So your derivative is going to be equal to, so let's take a look at our x squareds. We have negative 24 of them. So that took care of that term and that term. And then if I look at our x's, notice, let's see, we have 24x minus 20, so that's going to leave us with 4x. And then our constant is 15. So either way, if you notice, we got the same answer. It doesn't matter which way you write it. You can write your x squared terms first. You can write them at the end. It doesn't matter which order you write them in. Okay, so again, you can take your product rule, multiply, and then use your power rule, or you can use the product rule and you're still going to come up with the same answer. Okay. All right, let's take a look at number 2. So what I want you to do is I want you to identify U and V. So remember, U is your first factor and V is your second factor. Okay, so what would U prime be then? Good, 4 plus 6x. See, that's why you guys are my favorite class, because you guys are so smart. All right, V prime is equal to what? Good. All right, now, using your formula, so we're going to take here and we're going to take our U and we're going to multiply it by, now I'm going to use dy dx. This is just another way of saying the derivative. It's the same thing as if you wrote y prime. I just want you to get used to seeing all the different types of notation there. So we're going to do u times v prime. So we're going to do 4x plus 3x squared times negative 3. And we're going to add to it v, which is 6 minus 3x, times u prime, which is 4 plus 6x. Now we're going to carefully distribute. So we got negative 12x minus 9x squared. And you got a little double distributing to do here. So 24, we got 36x minus 12x minus 18x squared. So now go ahead and combine all your like terms, get everything where you want it to be, and you should end up with a negative 27x squared. Everybody agree with me on that? If you don't, too bad. You're going to have to take it up with me when I get back. Combine your x's, you got 12x, and your constants, you got 24. Okay, and then that's your derivative. Okay, all right, so there's the derivative of that. So let's take a look at number 3. So number 3 is just a little bit trickier here. So again, we still just have two products. So u is your first product, so 1 over x plus 1, and v is your second factor, factor is x minus 1. Now, when we find our derivative of this, remember, this could be written as x to the negative 1 plus 1. So anytime your variable's in the denominator, you want to rewrite that. It makes it a little bit easier for you to write your derivative. So this becomes negative 1 x to the negative 2. And then to rewrite your derivative using positive exponents, it's going to be negative 1 over x squared. So just keep that in mind that you might have to do a little bit of work to get your derivative. And then what's your derivative for v here? But just 1. All right, so now let's use our rule. So we have u times v prime. So I'm going to use the original u here. So f prime of x is 1 over x plus 1 times 1. Oh, that'll be tricky. And then we're going to do v times u prime. So we're going to take x minus 1, and then we're going to multiply it by negative 1 over x squared. Okay, multiplying everything by 1 in that first part. I know, it's a lot of thinking to do at the end of the day. 1 over x plus 1. All right, now I'm going to multiply here. Now, let me just come off to the side for a little bit here. I'm going to do x over 1, and I'm going to multiply that by negative 1 over x squared. You can reduce diagonally here. So this 1 is going to reduce to a 1, and that x squared is just going to reduce to an x. So when you multiply those together, you just end up getting negative 1 over x. And then if I multiply it by negative 1, that's just going to become positive 1 over x squared. All right, see anything you can do there? Yeah, that positive 1 over x and negative 1 over x cancel. So you're going to end up with the derivative is equal to 1 plus 1 over x squared. Now, if this was a multiple choice or, I gave you an answer key and your answer wasn't the same as mine, some of the things you want to check for is, did they write something that was equivalent to what you wrote? So what you could have done from here is you can say that 1 is the same as x squared over x squared. You agree with me there? Now, do you see why I did that? Because now I have a common denominator. So I can say that the derivative is equal to x squared plus 1 all over x squared. Okay, so if you happen to see an answer key, or if we do an activity where you're checking your answers and it's not exactly the way you have it, check to see if your answer is equivalent. Now, if this is on the test and I just tell you to find the derivative, either one of these answers is perfectly acceptable. Okay, you can give either one. Okay. All right, I want you to pause the video and go ahead and do number 4 on your own, please. Did I give you enough wait time to pause? Okay, just making sure. Now I'm going to pause it again and write your answer. Okay, if you got that correct, give yourself a pat on the back. Okay. All right. So that's it. Like there's really nothing else to show you when it comes to the power rule. It's all pretty much the same. So what I'm going to do is for 5, 6, and 7, I want you to try those on your own. I'm going to pause the video. I'm just going to write the answer. So I'm not going to show my work. I'm just going to write my answers down so that you can check your answers. So if you wanted to do 5, 6, and 7 now and check your answers and then move on to 8, 9, and 10, you can do that. Or actually, you know what? We'll do 8, 9, and 10 when I get back. So what I'm just going to do now is for the rest of class, I want you guys to finish out 5, 6, and 7 on your own. And I'm just going to write the answers so you can just check those. All right. And I'll be back in just a second. Okay, so here's all the answers for 5, 6, and 7. Okay, so 5, the derivative is 6x squared plus 12x. 6, your derivative is 4x plus 6. And then 7 is that beauty right there. Okay, so if you want to, you guys can work together in groups to figure out 5, 6, and 7. Just make sure you guys get them right. Okay, and then when I get back, we will go through and do a couple examples from 8, 9, 10, and 11, and we will move on from there. All right. Thanks for continuing to be my favorite class. I'll see you guys later.